Good evening, sir. I am Ashwantan, registration number 24BDS1204. Today I am honored to present a deep dive into QUIC and HTTP3, the future of internet transport. We often complain about slow internet or videos buffering, but we rarely look at the engine that moves the data. For 40 years, that engine was a protocol called TCP. Today, I am going to show you why we are finally replacing it with something faster, smarter, and much more secure. I have structured my presentation into 5 core parts. We will begin with the villain of our story, the the limitations of TCP and TCP or HTTP2, and then we will introduce our hero, that is QUIC, and provide a technical overview of its design. We will then explore its critical features and advantages, and finally we'll see the implementation of HTTP3 in these real world problems. Finally, we will wrap it up with the current adoption trends and what the future holds for the internet ecosystem. The problem: why TCP isn't enough. TCP legacy design. TCP was designed in 1974 for reliability, not speed. Sir, imagine the internet is railway. TCP was designed in 1974. Back then, we only cared if the data arrived. We didn't care if it was slightly slow. This created major problems today. First, head of line blocking. In TCP, all your data is like a single long train. If one car in the middle of the train goes off the tracks, the entire train must stop. Even if the subsequent cars are fine, they are not allowed to reach the station until the one last car is repaired and resent. Second, the handshake overhead. TCP is very polite. To start a connection, it must say hello, wait for the server to say hello back, and then send an acknowledgement. Adding encryption through TLS require even more back and forth round trips. On modern resource-heavy website, this small talk creates massive delays before a single byte of data is even shown to the user. So that's why we are not using TCP nowadays, and we are going with HTTP3. Handshake over it uses three-way handshake, and this causes latency and makes the makes massive delays before a single byte of data is shown to the user. HTTP2 limitation: multiplexing still limited by TCP constraints. One lost packet delays all subsequent data. Encryption TLS. This is what I told with an example in this slide. So we are going with QUIC. QUIC stands for QUIC UDP Internet Connections. Google recognized these bottlenecks and created QUIC, which stands for QUIC UDP Internet Connections. While standard UDP is considered unreliable, QUIC is actually clever. It takes the raw speed of UDP and adds its own custom brain on top to ensure reliability. It was standardized by the IETF under RFC 9000. Unlike TCP, which is buried deep in the operating system kernel and hard to update, QUIC lives in the application space. This allows it to be updated as easily as your web browser. Most importantly, security isn't an add-on layer anymore. TLS 1.3 encryption is integrated directly into the protocol's foundation from the very start. So QIC is actually developed by Google, and it is designed for modern internet and is actually helpful in handling mobile related tasks, video streaming and real time apps. Encryption TLS encryption built in from encryption is actually built in from the start. So yeah, key features of QUIC is reduce latency. First, the first breakthrough is actually reduce latency. The remember that polite TCP handshake. QIC simplifies it by combining the connection setup and the security handshake into a single step itself. So on the first time connection, this takes just one RTT, half the time of the TCP. Here is the magic part. Zero RTT resumption. If you have visited a website before, your device and the server already shared a secret. QIC allows the client to send the actual data request in the very first packet it sends. There is no waiting. This is why modern websites feel snappier and load instantly on high latency mobile networks. So if a particular packet gets lost during the stream, it doesn't matter, and the packets get delivered to the user, and independent the packet streams are very independent in nature. The since it is independent in nature, other streams get unaffected even if one packet gets lost during the process. So it combines TCP and TLS, which is not present in the TCP. And QIC actually helps in maintaining connection across various network. You can easily switch from Wi-Fi to cellular seamlessly without any issues. It uses connection ID instead of IP or IP port pairs. Now we'll compare QIC and TCP. Handshake here in QIC it's combined with encryption, whereas in TCP it's three-way handshaking. Encryption it is separated by two RTTs. So this is QUIC and this is TCP. Handshaking in QUIC it uses one RTT, whereas in TCP it uses three-way handshake. Encryption separate TLS negotiation TCP has, whereas in QUIC built-in TLS 1.3 is present. Total setup it requires 5 plus RTTs before data transfer, whereas in case of QIC only one RTT is enough. 0 RTT in case of assumption. Head offline blocking. Head offline blocking is actually present in TCP, whereas it is not present in QUIC. Connection migration is not present in TCP, whereas it's present in C. Congestion control. Congestion control cannot be modified in kernel, whereas it can be flexible in QUIC. As I said earlier, second pillar is how QUIC handles data. Instead of one long train, QUIC treats your data as a fleet of independent packet streams. If you are loading a web page with a video, text, and an advertisement, they are all separate streams. If the packet for the advertisement is lost, QIC doesn't care. It keeps delivering the video and the text streams to your screen without interruption. Only the missing advertisement is resent. The resilience is what makes HTTP3 feel so much smoother, especially when you are on a weak or crowded Wi-Fi signal. So it's more efficient compared to TCP, and it has backward compatibility over TCP. Real world performance gains: 10% increase in page load time, mobile network 20% improvement on high latency connection, and 50% reduction in handshaking time. In Google Chrome, it helps in faster page loads for the user. It is used in video streaming, which makes the video less buffering and for a smoother playback. Packet loss recovery: faster recovery without blocking other streams. In Facebook, it is used for significant improvements in video delivery. Reduced Cloudflare: reduced latency for global CDN. Uh, so we are currently seeing the current adoption status according to 2025 data. QIC and HTTP3 continues to gain momentum, demonstrating widespread acceptance across the internet ecosystem. The snapshot here tells the current adoption trends. Approximately 40% of websites now uses 40% of websites now uses HTTP3, a significant rise from 2022. That was like in 22%, nearly 22%. Tech giants Leading tech giants are Google, Facebook, Cloudflare, Akamai, and Fastly have extensively deployed HTTP3. Uh, it supports universal browser support for browsers like Chrome, Firefox, Safari, and Edge. All provide native HTTP3 support with enhanced user experience. Both iOS and Android platforms are increasingly integrating QIC support, benefiting mobile browsing. CDN integration: most major content delivering networks are now offer HTTP3 by default by reducing latency globally. Enterprises also continue to adapt to this trend of using HTTP3. It's it's still the consumers are still facing some issues, but it has great potential. Despite it has its own key advantages as well as its disadvantages. Disadvantages, mainly due to its rapid adoption. Several challenges still occur due to the lack of implementation and optimization for QIC and HTTP3. Middle box interference. Firewalls and proxies designed for its TCP often block or interfere with UDP traffic, impacting QIC performance. Kernel support. Native QIC supports various across different operating system, affecting server side performance and ease of deployment. Legacy infrastructure. Compatibility issues with older network hardware and software require gradual upgrades and adjustments. Even though HTTP 3 is backward compatibility, it still has some compatibility issues with older network, and it has some software issues which will gradually be improved as of now. New tools and techniques are still under development to effectively monitor and troubleshoot QIC connections. Now that we have seen the advantages, disadvantages, and the advantages, now we are going to see how HTTPS3 is actually implemented in websites such as YouTube, Facebook, or anything in fact. So we are going to see, one second. So we are going out of this, and we'll see the Chrome. We'll go to YouTube and see how HTTP3 is actually implemented. Now if we give inspect and network, and if you see protocols here, it has a mixture of H3 and H2. H3 means HTTP3 and H2 means HTTP2 and or TCP. It has a mixture of H3 and H2, which combines both fetch operation and fetch and script. So from this we can understand that H3 is actually HTTP3 is implemented in real life process, and it's not a future thing, and is actually present currently with and running with mostly without any issues. So now that we have seen the implementation of HTTP3 and how it's used in websites like YouTube or Facebook or any other websites, we are seeing how the future is headed for QUIC and HTTP3. Continuous refinement and development is going on in terms of developing HTTP3, and improved middlebox handling and UDP support, which makes it gives a better compatibility with the existing network and infrastructure firewalls, integration with emerging technologies, seamless operation with 5G IoT devices and other next gen platforms. uh, Seamless operation with 5G IoT devices and other next-gen platforms, enhanced security features, further advancement in privacy protection and DDoS mitigation techniques, wider enterprise adoption is expected, growing deployment in corporate networks and cloud services, new use cases beyond web browsing, expansion into gaming, real-time communication and other data-intensive applications. Integration with emerging protocols like ask for enhanced functionality. It is used to make internet more secure and faster. It gives better experience to users and gives better support for especially in mobile and other device handheld devices. It improves security and privacy on default, and it provides foundation for other internet services. So let's summarize what QIC is better where QIC is actually better in TCP. QIC is actually better in reducing the latency through combined handshakes, whereas in TCP there are three handshakes, and in terms of like QIC there's actually one. Number of head offline blocking for independent streams, connection migration for seamless network switching. HTTP3 is naturally evolving. It is basically designed for QIC's capabilities, simpler protocol without TCP workarounds, better performance for modern applications. Adoption is actually accelerating. In 2022 it was 22%, but in 2025 it is around 40%. It's actually improving. All major browsers are actually implementing HTTP3, and enterprises are also implementing. For the future is bright when we actually implement HTTP3, and it is a next generation. It is a foundation of next generation in internet. It provides better experience to users worldwide and enables new applications and use cases. Now we have actually explored how QIC and HTTP3 are fundamentally reshaping the internet, delivering a faster, more secure, and more reliable experiences for users and developers alike. These protocols are not just incremental development improvements; they are performing a major leap on how communication is processed, and it actually paves the way to for next generation in online applications and services. So thank you so much. I appreciate your attention and engagement during this presentation on QIC and HTTP3. Thank you.